Okay, here is another example. By using Jordan form, find the state and output equation for the following transfer function. You can see that's a third order system. So he gave us one pole. He's saying that it has a pole at -2. Okay, so I'm going to first write down the transfer function. Y by u equal to s plus 1 over s cube plus 8s square plus 21s plus 18. Now the denominator, as I mentioned, that's called characteristic polynomial. That characteristic polynomial has a pole at -2. So s cube plus 8s square plus 21s plus 18. I'm going to do the long division over s plus divided by s plus 2. So when I do the long division, I'm going to write down here, multiply with s square plus 2s cube plus 2s square. So I end up with 6s square plus 21s, s square plus 6s. So 6s square plus 12s. So 21 minus 12, 9s plus 18. So I'm going to multiply with 9s plus 18. Okay, and that's going to be 0. So this y by u, I can write this as s plus 1 over s plus 2 and s square plus 6s plus 9. Okay, now again I can write this as, simplify this as s plus 1 times s plus 2 and s plus 3 whole square. Okay, this is called repeated pole. Okay, so it has 3 poles total, but one pole is repeated at s equal to -3. That means you have 2 poles there. A pole is repeated. Okay, now y by u equal to, I'm going to divide this into 3 individual parts. A over s plus 2 plus b over s plus 3 plus c over s plus 3 whole square. Okay, if you have a repeated pole, you can only find that repeated pole term by using substitution method, and you can find other term where there is no repeated pole. You can find that by using substitution method, but the b, constant b, we cannot find it by using substitution. So for time being, I'm going to find a value by using substitution. A equal to s plus 1 over s plus 3 whole square. Substitute s equal to -2. I will end up with -1 over 2 square. So a equal to -1 by 4. My apology, here -1. If I substitute -2, it's going to be 1 square. So it's going to be -1. Okay, same way I can find the c value by using substitution method. So s plus 1 over s plus 2, substitute s equal to -3. So if I substitute s equal to -3, -2 over -1, so c equal to 2. Now finding b is a little difficult. Okay, so what I'm going to do to find b, I'm going to use substitution method here. So basically I have s plus 1 over s plus 2 times s plus 3 whole square must be equal to, now I'm going to do the LCM on the left hand, on the right hand side. So I'm finding LCM for this. So LCM for that is s plus 2 and s plus 3 whole square. So a must be multiplied with s plus 3 whole square plus b must be multiplied with s plus 2 and s plus 3. C must be multiplied with s plus 2. Okay. Now the denominators are same, so numerators must be equal. So to find out c, actually we need to find the b term. So to find b term, all I need to do is equate the s square term. So here the s square term is 0. Here I have as square, so a plus bs square, a plus b equal to 0. I already know a value, a equal to -1, so b must be +1. Okay, if you don't know the c value, again you can equate other term like constant or the s term. So if I equate s term, here I have s, so 1 equal to, so s square plus 6s plus 9, right? So you will end up with 6a plus 5b plus c must be equal to 1. So if you substitute all those values to just verify, 1 equal to 6 times -1 plus 5 times 1 plus 2, is that right? So -6 plus 5, which is -1 plus 2, 1 equal to 1. That's you can clearly see. Okay, you don't need to do that, I mean just want to verify that. So now I have y by u equal to, what is my a, minus 1 over s plus 2 plus b over 1 over s plus 3 plus c, which is 2 over s plus 3 whole square. So if you have repeated pole, that's a little bit different drawing, simulation diagram. So I'm going to draw the simulation diagram first. Okay, so if you look at the first one is simple and the second one is also simple. So here is the first one. Here is 1 over s. So here it's 1 over s. So I have plus, so basically this must be minus here. Okay, and 1 over s plus 3, same thing there. Okay, now since I have repeated pole, okay, so what we're going to do, I'm going to write another repeated pole or simulation diagram for the repeated pole in series with the first pole. Okay, now to get y, okay, for simplification purpose, what I'm going to do, I'm going to take this u to the other side. Okay, to get y, this must be multiplied by u, must be multiplied by u, must be multiplied by u. Okay, to get y. Now u has to pass through this signal, but that's a negative. I'm going to put the negative there, so that is my u, and u must pass through this 1 over s plus 3, which is right there. So u must be passed through that 1 over s plus 3. Now u must pass through the two poles, so u must pass through the two poles but multiplied by 2. Okay, this is my u and this is my simulation diagram y. Okay, that's a complete simulation diagram. Now I'm going to take x1 dot, x2 dot, x3 dot. Okay, what is x1 dot? X1 dot equal to minus 2x1 plus or minus u, and x2 dot equal to 3x2 plus x3 plus u, and x3 dot equal to minus 3x3 plus 2u, and y equal to x1 plus x2. So I end up with a equal to minus 2 0 0 0 3 1 0 0 minus 3. okay, and b equal to minus 1 1 2, and c equal to 1 1 0, and d equal to 0. There is no d in this. So if you look into this Jordan form all the time, okay, all the time Jordan form, you will end up with only the diagonal elements, okay. But if you have a repeated pole, I mean, if you look into the previous two videos, you will have only this. But if you have a repeated pole, for sure it will end up with a 1 there, okay. If you see this format, I can clearly, I mean, with my experience, I can tell this is a this system has a repeated pole, okay. Thank you. I'll solve a few more examples in the next video.